Hello everyone, this is Amir from Audio Science Review. I have another product review for you. It's this Bluesound Node Icon. It's their top-of-the-line streamer, multi-room audio. Sorry I haven't peeled off the protection on it. I'll leave those on when somebody sends them to me that way. If you don't know what a streamer is, they are a product where they let you pull content across your home network or externally. So you can play Spotify from the internet, or if you're like me, you have a player called Rune, you can actually push content to it. So I call these push and pull modes. Pull is when you use the UI on this device to pull the content and have it play from a service. And push is when a media player like Rune is able to stream to it on a home network on this thing. So let's go through the review that I posted yesterday. The device has a graphical display over here, which is nice and large. But strangely, it's not a touch screen. The touch buttons are on top, which is kind of unusual design. Some people, I guess, like it. I'm not among those. If you're going to give me a screen to this day and age, give it to me as touch. I didn't use it that way anyway to have an app, and I downloaded the app. I found the app quite difficult to use for my testing, which is when I first started it, it was in Toslink optical input, and I wanted USB input. And it took me about 15 minutes to figure out how to find the input selection. There's an audio tab in there. I went in there. There was no input selection there. There's a player tab in there. There's no selection for inputs. Turns out there's a button at the bottom that says music. And if you click on that music, you can then select inputs. To me, music buttons for streaming services or browsing your music library, it isn't for finding what input you're on and changing that input. So that was a little bit of disappointment. What was not a disappointment was just looking in the back and seeing just incredible amount of connectivity. Streamers used to have just a pair of RCA outputs and a network input, and they would call it done. This has XLR, a balanced output, which is my preferred way to connect anything that's especially digital and analog, mixed analog products like this. But it also has analog inputs over here, so a pair of RCA for that. And you, of course, have digital input. There's a optical input, but it also has subwoofer out, and I think it lets you program the amount of the filtering for that. It even has a digital output in here. What's nice is that it also has HDMI eARC and HDMI ARC, which I also tested, and USB-C, so you could use this as a local DAC, and I tested it that way. And it has trigger input and output. So from functionality point of view, it's quite rich. Some streamers come close to this or have similar kind of I/O, but this is definitely a lot of functionality in there and lets you integrate everything into this device. You could have a turntable that you could bring into the analog inputs, for example, and then you could hook it up to a computer, and then meanwhile you can also stream content to it. So quite nice functionality. I'm about to go through the measurements. I highly recommend that you watch my video called Speed Reading DAC audio measurements, because that's the first thing that I'm going to test is we feed it some digital output. How does it perform either across the network or locally? So I started off with my Rune player, which nicely discovered this. This is Rune certified, which is nice. So it just showed up as an output device in my Rune player. I selected the node icon and I pushed the content to it. And as you can see down here, the spec is 0.004% total harmonic distortion and noise, and I'm actually getting half as much. So nice that we can beat the spec on this thing. You can see the spectrum over here of noise and distortion. Noise floor is quite low. These are the distortion spikes. There's some noise in between these things, and those will be seen better in other measurements. But as is, this is very respectable performance. If you put it in, 500 devices that I've tested, whether DACs or streamers, it certainly lands in this excellent category in blue. And if we zoom in here, we can see where it is. There's some of its competitors in here, like this Eversolo is up here, Matrix Mini i4 is way up here. So is it much better than other Bluesound products? Yes. Is it more than good enough? It is. But, it's a few dB shy from being state-of-the-art as far as streamers go. on this thing. Then the next question was, how good does it work locally? And is there a difference between network playback versus local playback? And there's not. So this is in, sorry, let me scroll down. This is XLR output using HDMI ARC input to it, and it performs the same, and it doesn't care then whether you're feeding it HDMI or streaming. And then I also tested out the RCA output. Usually there's a hit in RCA output. The voltage levels are lower, and so we take a bit of a hit in here. It's still more than good enough over here. One thing I didn't like is these oddball output voltages. This should be 2 volts instead of 1.8, and these balanced outputs should be 4 volts rather than 3.67 or something. I don't know where they got these numbers, but you know, the norm today is 4 volts for balanced and 2 volts for this. One of the great things about this DAC is very, very low noise floor, and you can see this. From XLR output, you have 21 bits of dynamic range, which is incredible. So very, very good. There are better numbers to be had in dedicated DACs, but not by much. So 125 dB, that means if you play at 125 dB SPL, the noise will be at the threshold of hearing. So it's quite good. Even RCA out produces almost 20 bits of output. So quite nice in here. This is on multi-tone. This is a 32-tone test clip, and we can see that the distortion floor is exceptionally low, down to about 22 bits. And this is basically near state-of-the-art if it's not already there. I run this strange test that Stereophile runs. It's a 50 hertz tone. And instead of the impedance being very high and represented what an amplifier would be, they set the load to the output of the streamer or DAC to be only 600 ohm. And see if there's more distortion generated. I never see that any DAC that's well designed cares, and indeed that's the case in here. We see that the distortion products are incredibly low, well below threshold of hearing. So it's not a test I like, but if you go on Stereophile, you'll have a hard time comparing my measurements. So there are very few common measurements, but I've added this, in the last year or so you can at least compare this with Stereophile measurements and see how this product fares compared to some of the other ones. Linearity is, we're looking for flat line in here, just gets a hair wiggly in here, and that's common, and it's certainly very, very, very good and excellent performance. So no worries there. Where the worry comes in is this in jitter test. We have this primary tone at 12 kilohertz, and ideal DAC would just have this vertical line and nothing else. And I shouldn't say nothing else. There'll be a sequence of pulses in here that should be there, but none of this other stuff should be there that you see in here. And this widening of skirt, as we call it, that shouldn't be there either. This widening indicates that the clock of the DAC is jittering back and forth at a low frequency and randomly. And when it's randomly, you see this sort of exponential drop-off in here. And all these other ones are just sources of interference in the DAC. Are they audible? These spikes certainly are not. They're at minus 140 dB, so they're not. And this widening in here, it could be audible, but I'm not going to go on a limb and say it is at these low levels. Is it good engineering? No. I mean, this is not something I expected to see based on the previous information, previous measurements. And that's why I run a suite of tests. It's not just one SINAT measurements that people claim. We run a bunch of tests and probe the device from different directions to see what problems we can find. But the biggest miss is this, which is a choice they've made. Every DAC needs to have what is called a reconstruction filter, which means that it shouldn't allow anything more than half the sampling rate to come out. So this test is at 44.1 kilohertz, the CD 41.1 kilohertz sampling rate. So we don't want anything after 22.05 kilohertz. And that's where this vertical cursor is placed at 22.05 kilohertz. We see that, so instead of a brick wall where nothing is after here, we see our signal, but when it gets here, it's hardly down just 2 or 3, 4 or 5 dB, and the signal keeps going. This should be rolling off down here. Most DACs have somewhat of a lazy filter as a default, which is by 24 kilohertz, they get a lot of attenuation. So a little bit of incorrectness in there. This one, it just goes on and on. The reason for this is that Lindbrook, that's the parent company of Bluesound, has acquired MQA, which had this kind of slow, lazy filter with their belief that, there's no pre-ringing in there, so therefore it sounds better. Even if one were to believe that it does sound different or better, I would have hoped that they give you a choice to a user to have a standard filter. The DAC chips they use supports that. It'll be a couple hours of programming for them to have provided this option. I should say that Marantz used to ship all their AVRs with this, but after I started to measure their AVRs and discovered this and popularized it, to their credit, this year's latest generation of Marantz products now have a setting in their AV receivers and AV processors where you can have this slow filter, or you could have the one that I'm talking about, which is a sort of compromised sharp filter. And I hope that Bluesound does the same thing. It's up to them to think that, salvaging this out of MQA is a good idea. More power to them if they can prove that. But for the rest of us, we don't want to dump all this ultrasonic energy into the tweeter and the amplifier coming out. Is it audible? I can't tell you. Most likely, probably not audible. But from design engineering and basic math and signal processing, it says this is wrong filter. So give me a choice of the proper one. Fortunately, if we do a frequency response sweep and we measure at 20 kilohertz, it's only down half a dB. A lot of these slow filters actually start to reduce the response as low as 10 kilohertz. The Marantz did that. That's around 10 kilohertz, 5 kilohertz or so, it would start to droop down. So they actually had less highs. And some people think, oh, that's less digital sound. In reality, it's not a correct sound. So one of the penalties of having that slow filter is this test. This test measures the THD plus N or SINAD over a wider bandwidth, so 90 kilohertz instead of just the audible band that the dashboard uses. And because the filter doesn't attenuate ultrasonic components as it should, as the test frequency goes up, the amount of spectrum bleed or garbage, ultrasonic increases. And as a result, you get this kind of performance. You can see this red line just goes through the roof. So, at least before it even gets to 20 kilohertz, we're up to 1% THD plus N. Now, that noise is, again, ultrasonic. It's not necessarily something you're going to hear, but it could cause some intermodulation effect with tweeter, and maybe it's audible. And I can prove that it's the filter that's doing this, because if I run the same test, but I run the test signal at 192 kilohertz, the moment I do that, you get this line at the bottom. So you can see that effect is completely gone. The reason for that is that the high sample rate, this slow filter they have is outside of the bandwidth of this test, so it really doesn't make a difference. So if they don't fix this, in players like Roon, you can actually tell it to upsample everything to 192 kilohertz or 176 kilohertz, something high, and it'll do that for everything you play if you tell it to do that, and you can get this response in here. But I hope the company goes and spends an afternoon and adds that choice to the filter. So that's the DAC output test. It's a mixed blessing. It sort of does some things very well, some other things doesn't do well. But let's test the preamp input, which I call. So if you feed an analog input, what do you get? As soon as I hooked it up, I started to get really high channel imbalance, as you can see in here. That's caused because of the ground loop in one channel was much harder than the other one. And I play around with it multiple different ways. My analyzer actually has a floating ground, so I'm able to ground it, not ground it at one end and not the other. And some of the modes would really reduce the performance, have a ton of ground loop and hum and noise. And this is the best I got. In your system, it may be better, or it may be worse. You may get hum and buzz out of this and on this thing. So I can't say there are specific design choices they've made that's wrong, but certainly in my testing, this was a lot more problematic. If it had balanced input, that would have been perfect. It would avoid this problem, but it only has RCA inputs, sort of invites this kind of problem. Again, we run into this oddball output voltage. So if I fed it 2 volts, I expect to see 4 volts output out of XLR, and I'm getting 3 volts output. It's just a weird transformation. It's like, why they decide on this and didn't pay attention to sort of the factor standards. Good and bad news in frequency response. Good news is that it's dead flat response to inaudible band, even below audible band down to 10 hertz, which is good. A little bit of bad news is that the analog input in this is digitized, and then it gets converted back to analog when it comes out of it. And the digitization they've done, it appears to be at 44.1 kilohertz. Every ADC you get today starts at 44.1 kilohertz, then goes all the way up to probably 192 kilohertz. The competitors to Bluesound actually give you a choice of that sampling rate, and there is no such choice in this app that I could find, they sort of chose 44.1. The norm is, if they don't give you a choice, is at least pick 48. That gives you a bit of a margin out here. I mean, some people believe analog is better because it doesn't have this, sort of a brick wall response that digital has. And to at least satisfy them, you want to allow some of this output to bleed through. So it would have been nice if this was 48 kilohertz or 96 kilohertz. So this is something that could fix in firmware if they wanted on this thing. Lastly, I believe they claim that their headphone amplifier is actually high performance, uses THX technology. That was not my experience in measuring it. To a high impedance load, 300 ohm, is what you get out of a, let's say, Sennheiser HD600 series. It starts off with very low noise, which I like. Then all of a sudden, something strange happens. Well below even gets to 1 milliwatt. The distortion jumps and it sort of flatlines, which is kind of strange, tells me there's more distortion than noise. But the worst thing is that it clips at 43 milliwatts. My sort of informal standard is that any desktop AC powered device should at least get 100 milliwatts. If it gets 100 milliwatts, it's able to drive these headphones properly, and potentially if you have a 600 ohm impedance and so forth, or a headphone that's not sensitive, and will get it to sufficient loudness. Is this good enough for everyday use? Yeah, you can see that my reference for low output from this old topping is lower, but in high gain, that topping beats it above 100 milliwatts. So it's not great, combined with this is not great. When you feed a 32 ohm or 33 ohm for lower impedance headphones, a lot of planar headphones have low impedance like this. It doesn't have that glitch, and the noise and distortion remain very low, and then it clips. It produces 152 milliwatts. Not great. Again, I'd like to see, a few hundred milliwatts, but this should be good enough to be everyday item. So it's a step above what I call checklist item. Checklist items is you buy an op-amp, stick it in there, and you call it done. So some attention was paid to produce more power, but whoever designed it clearly is not aware of what performance we can get out of even cheap headphone amplifiers today, which run circles around the Bluesound icon. So where are we then? What's the conclusion? It's much better than any Bluesound product I've measured in the past. Most Bluesound products are just okay or good enough kind of thing. So they've really taken a step forward, but just a couple of missteps with that filter setting, for example. It just doesn't make sense to me. And usability of the app is a little strange. And the jitter, that's just should be a standard measurement every designer should run, and if they run it and solve those noise sources, they should have gone and found and get rid of them. One issue with not catching those is that the source of the noise is unknown, and it could get worse in your scenario versus mine or something, and it could be worse than that. So those things need to be found. The analog input performance actually I think is quite good, even though the sample rate is low. What I don't like is the headphone output. It just should be better than a $1,000 device. So personally, because of that choice of filter, I'm not going to recommend it. Just no reason to force one filter down everybody's throat. They should give a choice. If they do that, I would recommend it. Okay, that's all I have for you. Talk to you later. Bye-bye.